Inverse functions using graphs. So what you're going to see is just a different representation of what the previous section was from tables. So whenever we had a table and it was saying that the function is invertible, which is what this one is saying, awesome, then that means that we're given the original function. All we have to do is find its inverse. We can do that by looking at the graph, choosing points, and then rewriting those points in a table, and then flipping the coordinates, just like we did in the previous section with tables. So we can always extract coordinates from a graph and then rewrite the inverted table. So that's exactly what I'm going to do on these two examples. I'm going to take a look at this line on the left, and then I'm going to find what is the inverted function's function of positive 4. Well, let's start with an xy table of what the current coordinates are. So let's go 0, 0. 3, 2, and 6, 4. Okay, so we know that if it's invertible, which these are, then all we got to do is switch the x and y values, and then we will have our inverted table. So the question was, what is the function of 4? Talking about its inverse. So the function of 4 would be 6. So keep in mind the original function is talking about x. The inverted function is talking about y as the input. So if you wanted to read a table backwards, I mean, you could do that. You know, your y is your input, so 4 to 6. I think it's easier to look at the inverted table. Let's go ahead and take a look at the second example. I'm going to choose a couple points that I see are obvious. I'm going to make a table. So x, y, 0, 1, 1, negative 1, and 2, negative 3. We know that whenever we have a function that is invertible, all we have to do is extract the points from the graph, then flip our x and y. Instead of x being the input in the inverted function, y would be the input. So we're just going to flip it so we can see what the relationship is to find the function of 1. So it's going to be 1, negative 3, 0, 1, 2. Now what we're doing is we're looking for 1. What does 1 coincide with? Y would be our new input, so that means we're looking at 1 and what it's connected to, which is 0.